Hi class. Now let's talk about cold fronts. We've drawn cold fronts a number of times in class, so you should be kind of used to them. So a cold front is a blue line with blue triangles pointing into the direction that the front is moving. If we draw this in 3 dimensions, or try to anyway, it will look something like this. Okay, so um, here we have a cold front that's moving from the left to the right. Now the air behind the cold front is going to be our continental polar air. It's polar, so it's going to be cold. It is continental, so it's going to be dry. So we got a cold, dry air mass, and that's going to make this air dense. So the air behind the cold front is going to be a dense air mass. And we can add one more thing. So we mentioned on the previous video that a front is a leading edge of an advancing air mass. And so this particular air mass is continental polar, and it is represented on the weather map as a high pressure. So the high pressure is on the move. The leading edge of that high pressure, which is a continental polar air mass, is the cold front itself. Okay. Now you'll notice that also here the the leading edge is fairly steeply sloped. So we have a steeply sloped leading edge. Okay, and how steep is that? We mentioned in the notes, it's like for every 1 mile up, it's 100 miles across. Okay, and so in the real world, that's a fairly steeply sloped cold front. We also mentioned that cold fronts move relatively fast, so about 20 to 25 miles per hour, and that the combination of these two being relatively steeply sloped and moving at a faster rate means that the air is going to move relatively fast, or is going to rise relatively fast. And the faster air rises, the more potentially severe the weather can be. So the more potential, the key is there's potentially. Certainly not all thunderstorms are severe, but the faster you can get that air to rise, the more potentially severe the weather. And so you'll notice that when we get a really strong outbreak of severe weather, it's because we've got a really strong cold front, really a huge difference in the temperature and moisture content of the air behind the front versus ahead of the front. Okay? Now, ahead of the front is going to be, by definition, maritime tropical air. And we know that maritime tropical air is warm, relatively warm, and moist, and therefore less dense. Okay? And so as a result, then the more dense air is going to force that less dense air to rise. Okay? And so we also talked about a pattern of clouds. And so way out in front, here you'll have some altocumulus clouds. Altocumulus. And as you get closer to the front, those will turn into cumulus clouds. And as you get closer to the front, and again, this is a textbook example, so this doesn't happen every single time. But as we get closer to the front, now you start getting some towering cumulus. And right near the front, so in close proximity to the front, is where you'll find the cumulonimbus clouds. So cumulonimbus clouds are really thick, lots of water involved with that. And so as a result, the precipitation that's going to be associated with a cold front is typically going to be of greater intensity because there's so much water to work with. Okay, and you got rising air due to your steeply sloped leading edge of the cold front, and the faster movement of the cold front is going to lead to greater intensity. And but this is also going to be of shorter duration. Shorter duration goes back to the movement of the front. It's a fairly quickly moving front, and therefore it's going to mean a shorter duration of precipitation. But the more steeply sloped edge will lead to greater intensity. The depth of water that you've got to work with will lead to greater intensity also. All right, we'll take a look at warm fronts next.